Hi, I'm Murat Ögat. I'm the co-founder and manager of Kuka Apps, which is a mobile application development company in Istanbul, Turkey. I would like to talk about how we use the Google Maps and Directions API and the Location Manager in the Android platform to create an app which tracked the user movements to mobilize the users and create awareness about the breast cancer. While creating an app that constantly tracks the routes of the users, the main idea is to constantly get the locations of the users and compare it and calculate the distance between them. So the main problem we had at the start was to get the locations of the users constantly. There were two methods for getting the location, and one for Wi-Fi and the other from GPS, and we had to experiment with both of them. The Wi-Fi location can be obtained almost instantaneously, but it can be very inaccurate, up to 50 meters sometimes. And this was unacceptable for us because it added up really quickly and displayed the user a wrong estimation of the walking distance. The GPS location takes some time to warm up, but after a couple of seconds, it can give very accurate locations for up to 1 meter or 2 meters. That's what we needed, so we opted for using the GPS location. Although the points from the GPS could be very accurate, even with 2 meters or 3 meters of inaccuracy, they could be placed on a building instead of a road, and the users were generally walking on a road. If we take the raw points from the GPS and display it on a map, this would draw a road that would go constantly inside buildings and outside of buildings, and sometimes even over the sea. So we used the Google Directions API to solve this problem. Basically, what we did was to get the point and not use it as a raw data, but send it to the Google Directions API and ask for a route starting from that point to a point that we have measured before. What the Google Directions API returned was a route from these points, and the first point of this road was actually guaranteed to be on a road. We also had to implement our own location manager that filters the data and determines whether they are usable or not before passing it to the app engine. You can see here that the function's main purpose is determine whether a newly received location is better than the previously received one. First, if the accuracy of the received location is less than 30 meters, we just attribute it to a bad GPS signal and ignore it. Otherwise, we compare it to the previous measurements. If the measurement is not less accurate or is obtained more recently, we set it as the new location of the user. All apps that start services in the background and especially use GPS data must be very aware of their battery usage. If this is not done well, it can quickly drain the battery of the device of the user. The app only records the data points while it's in the background, and we try to defer every calculation or web service queries that would consume battery until the app has been put to foreground again. The total distance covered by all the users will be set as the basis for the donation, and we didn't want our client to pay an extra amount of money for distance the users they actually didn't walk. And we of course had some server-side and client-side checks for that. And what we did on the Android platform was based on speed and location of the user. And the speed we could get from two different sources. One is based on the location points. We got the average speed, and also the location manager can give you an instantaneous speed with all the location it delivers. So we checked the speed values, and if it was above a certain threshold, we stopped the walking immediately. This prevented the user from recording bicycle rides or car rides, or it filtered out the users who started walking and then forgot about the app and entered the vehicle. And that sums up how we solved some technical problems while we produced a walking tracking app that uses GPS data. Thank you.